Yeah, so hello to everyone who's joined us for this webinar. My name's Steven Renwick. I'm one of the co-founders and the CEO of Tilores. And you probably know already, but we're an entity resolution company. And every Wednesday, we try to do 1 or 2 webinars, one at 12 o'clock Central European time and one at 5 o'clock. So people in the US can potentially join as well. And format varies. Sometimes we're just talking about entity resolution, sometimes we're just talking about Tilores, but I want to try to speak to more data experts, if possible. And I'm very happy and excited, therefore, to have Max Latey here with us. Max is someone that we met over a year ago. I guess it would have been 2024. Yep. A bit randomly, and things accelerated very quickly, and we've worked together on at least 2 entity resolution projects in 2025 that were both pretty significant for a couple of different reasons. And Max is a real graph database expert, and that's in comparison to myself as well, who's definitely not a graph database expert. So I'm very graph databases are a much kind of bigger, well-known field than entity resolution, but they are very related. So I want to get the perspective of a graph database expert on entity resolution. And with that in mind, I think I'll first of all stop talking and let Max introduce himself. Max.
Yeah, thanks for the intro. That was great. Yeah, my name's Max. I'm the founder and CEO of Pinboard Consulting. We're a dedicated graph technology consultancy, and that includes entity resolution. So even though some entity resolution products don't necessarily use graph tech explicitly under the hood, almost all of them use some kind of graphy approach. And so although our main focus is graph databases, graph processing engines, graph analytics platforms, etc., things like, memgraph, spanograph, Neptune, those kind of things. We also look at, obviously, Tilores, and it's been fantastic partnering with you guys over the last sort of 18 months. As you say, we've had some great successes together, and looking forward to some more in 2026.
Great. I like that. I think Michael commented on LinkedIn that I think he's caught our little discourse at the start where we weren't really sure if we were live or not. So thanks, Michael. Yeah, you catch our leathering nonsense at the start. Well, let's jump into the topics. And I think the first thing is I would like to ask is from a very kind of general conceptual point of view, if you could explain what a graph database is. I mean, most people know what databases are. That's pretty difficult to avoid. But I think we're used to thinking of them in terms of like tables with rows and columns, right? I think everyone's kind of grown up with those now. But for many people, a graph is something that you show with bar charts or something like that. So maybe you can give us a brief, explain it like I'm 5 or maybe 15 or something, explanation or introduction to graph databases.
Yeah, very happy to. You're right. The graph industry generally does suffer from a terminology problem because a graph can be a graph of any mathematical function, and people are used to seeing graphs of, for instance, the x-squared function, right? When you're at school, you plot the x-axis, you plot the y-axis. I think I just mimed those in reverse. But you plot the x-axis, you plot the y-axis, and then you plot the x-squared function or the x-cubed function or a sine wave function. Those are graphs. However, when you're doing a bar chart or a line chart, they're not mathematical functions, right? They're charts of sales figures, they're charts of inventory, they're charts of proportions of, age brackets, those kind of things, right? And because people are so used to seeing, a horizontal line, a vertical line, and then some kind of squiggly line at school, and that is a graph of a mathematical function, when they then see a chart of time series data, they're used to calling it a graph. It's very hard to convince people it's not. The easiest way I've found is to get them to open up Excel and click on that button and say, what are those called? And they go, oh, they're all called charts. I'm like, yeah, because they're all charts. Yeah, I think I'm on a losing battle here, but
I think you're explaining it like a 5 explanation is assuming a very intelligent 5-year-old. But I mean, where I'm used to seeing graph databases, my background is strangely in like biochemistry and genetics. So I'm used to seeing, you know, the ball and stick models of molecules, you know, which can obviously get extremely complicated, but at its simplest, you've got something like, you know, oxygen, which is 2 nodes of oxygen linked together by a bond. But actually, I didn't even realize that that is also considered, that is part of graph theory. Nodes and edges of atoms in a molecule are actually graph theory as well. So I think that's the difference for people is when you show them a so-called graph, and you know a graph data like we're talking about, it's something that kind of, to me, visually makes more sense for the representation of a data, whether that's a knowledge graph, which is your kind of domain, or the entity resolution related graphs.
Yeah, absolutely. I think when we get to the presentation and we see some actual graphs of networks, some graphs of entities, the distinction will become clearer. But what a graph database, how it distinguishes itself from a normal database is, to your point, normal databases either store things as rows and columns, or in some cases they might store things as keys and values. They may store things as documents. So recently we've had, I say recently, in relatively recently compared to relational databases, we've had things like MongoDB, etc. with document databases. We've got these multimodals like OrangoDB, where things are largely stored in sort of JSON style. Graph databases store things as nodes and edges. Nodes being objects generally, either physical objects or conceptual objects, like an oxygen molecule, a carbon molecule, a hydrogen molecule, or a train station, a passenger, a location. And then a relationship or an edge being some relationship between those. So in your example, it could be a covalent bond. It could be a train track. It could be a social relationship. It could be, if you're looking at very, very granular real-time interactions, it could be a conversation. So you could model 2 people having a conversation as 2 nodes, with the relationship between them being having conversation, which could have a duration. And then if another person joins the conversation, maybe another node comes in, that edge has, you know, conversation as well. So yeah, graph databases and graph processing engines are geared up to store and query that kind of data, rather than, say, relational and tables, which are far more about storing slightly more, static, less related data.
And so in like in a financial services setting, the nodes could be people or bank accounts or something like that, and the edges are therefore someone sending money from person A to person B, and that represents some kind of relationship, right?
Yeah, transaction is a classic use case. Sometimes you might want to model transactions as nodes if they have relationships of their own, but classically, yes, Max sends money to Steven, or Steven sends money to Max, with the quantity on the edge would be the classic example of an edge with some kind of edge attribute. And the edge attribute could be the date of the transaction, the currency of the transaction, the quantity of the transaction. They would be stored on the relationship. Yeah.
And so, I mean, one of the reasons that graph databases are so interesting to us at Tilores is we experience very frequently that when people come to us wanting to do entity resolution, that they've already tried to do this using a graph database. And I should probably just very briefly define entity resolution, even though I'm admittedly terrible about this. But it's, entity resolution, we would consider the deduplication and linking of record data from one or many sources to identify unique things or entities. And most of the time that's a person, a natural person or a company, but it could also be an object, a place, it could be a product, it could be anything. But it's different from graph databases in that we are trying to establish these distinct entities rather than suggesting relationship between things. But conceptually, it makes sense that you might try to use a graph database for this because you've got a lot of data and you're trying to say these things are related. So we actually tried to use graph databases before we built Tilores. And so you must have encountered people doing the same. So maybe you can give us a kind of intro to how entity resolution has entered your world, your experience of it, and where it fits with your kind of graph database expertise.
Yeah, absolutely. Let me share screen. I've kind of prepared a little, very basic kind of walkthrough of, I guess, how the situation has come to be where graph is, in my view, sometimes being incorrectly used for entity resolution, where something else should be used, and where graph should be used for entity resolution, and where other things should be used. So if we think about entity resolution as a whole, unfortunately, again, we fall into this terminology problem where there's kind of two types of entity, and people use them, the same word for two different things. So when people say entity, generally, because most people are used to columnar or key value data stores, what they mean is a row or a key value set. So for instance, they would look at this table in a database and go, I have 4 entities. We need to resolve those, and say, are they the same? Are they different? Do they resolve? Do not resolve? So for instance, in this table, Max Latey and Max Latey probably do resolve. They're probably one entity, right? The chances of there being a Max Latey and a Max Latey, quite small. So you would maybe flag that or automatically match it as an entity. Same with Steven Renwick and Steven Renwick. It's possible that these are 2 different people. Both the first name and the second name have different spellings. Potentially they are different people. So you may want to look at email address or phone number or something and resolve these. But ultimately, whether it's key value store or columnar, you would look at these and go, these are 4 entities. Whereas in graph, if I kind of scroll down a little bit, an entity might be a node. For instance, my wife, Helen Latey, if we had 3 entities in this graph where Helen Latey is married to Max Latey, Helen Latey is married to Max Latey, well, by the general cardinality of marriage, which is normally 1-to-1, this would not resolve. You would probably go, you know what, these should probably resolve to one entity, these 2 graph entities. Because these contain text, kind of look at them and go, well, maybe these entities and these entities are kind of the same, but really they behave very differently. So this is an example of a graph entity resolution. If we make it a little bit less simple and go, well, actually, now let's do something a bit more complicated. Let's go and look at 2 ultimate beneficiary owners, right? Ultimate beneficiary owner is a huge use case for graph and somewhere that uses entity resolution. You might want to go, we have these 2 entities. They both have shareholdings in these 3 companies. They both live in the same country. They both bank with the same bank. For the purposes of fraud, taxation, crime, we may want to go, well, is John Smith actually an alias for Kurt Mueller? Are they actually one and the same entity? This is kind of graph entity resolution. So for graph entity resolution, where you're trying to work out on the basis of relationships, which nodes may actually be resolved entities of the other nodes, graph databases are great. But for text, where your entities are stored like this, and they're actually text entities rather than nodes and relationships, because you'll notice here, no relationships, right? We're just trying to resolve effectively blocks of text. For these, graph is actually terrible, and I do mean terrible, as you would have found out when you first started looking at it. If we look at something like text resolution graph, you can see here already this is starting to get complicated. So we've got Max Latey, Max Latey, Max Latey. These are all variants that I've had in my life. And then you start looking at things like address, where you've got 123 King Street, but also 123 Kingster, and you've got a postcode with a space, and you've got a postcode without a space. Trying to do text-based entity resolution on a graph is just terrible. You just get huge, basically combinatoric explosion. You start to get proliferation of nodes, a proliferation of edges. Building the logic becomes hard because the way you're trying to resolve has nothing to do with the relationships, right? Maybe a little bit. You might kind of go, well, these have the same edges. Maybe these two could be resolved based on some kind of graph matching, but you wouldn't resolve this one and this one because they only share one edge. They don't share the other. So it's really, you can do it in graph. And because there is such a thing as graph entity resolution, people, I think, often miss the fact that they are different things. Text-based entities and graph-based entities resolve differently because they are fundamentally different things. This is about blocks of text, and are these blocks of text similar or not similar? And for something like this, Tilores is amazing. I mean, I know we're on a Tilores webinar, and at the risk of being not quite so neutral, Tilores, I think, is best in class at dealing with text-based entities, but you wouldn't use it to resolve John Smith and Kurt Mueller because John's nothing like Kurt and Smith is nothing like Mueller. For this kind of entity resolution, I would say a graph database is absolutely the way to go. Whereas in the opposite direction, if you've got, say, let's say this wasn't all in one table. Let's say you had 4 customer tables. You had a customer table marketing, a customer table in sales, a customer table in outreach, a customer table in tech support and support tickets, and you wanted to start merging all those tables and going, well, I've got a Max Latey who had an order, I've got a Max Latey in my CRM, and I've got a Max Lately who raised a trouble ticket. Are they the same person? Well, those are text entities. And you would absolutely want to use a text-based, rules-based entity resolution solution.
So that would suggest then that graph databases actually would benefit from having a distinct entity resolution step before you're putting data into the graph database, because otherwise, in this case, you would end up with multiple Max Lateys and multiple Steven Renwicks. So,
correct. If you loaded these directly in to do graph entity resolution before doing any kind of text entity resolution, you're going to have horrible problems. Yeah, ideally, you just want one John Smith that's been resolved, something like Tilores, one Kurt Mueller that's been resolved by Tilores, one ABC Construction, one Amazing Materials. So yeah, entity resolved knowledge graphs or entity resolved digital twins, entity resolved graphs are absolutely will perform better if you put something like a text rules engine prior to loading the nodes into the graph database to then do graph entity resolution.
Okay, cool. I should also just add, if anyone's got any questions, they can post them in the discussion on LinkedIn. And there, like I said, there's about a 20, 30-second delay, so I will see them and we can try to answer anything. So then we worked on a couple of very interesting projects together last year. And one of them in particular was solving a problem which the customer had tried to solve before themselves and not succeeded. And we can't name the customers yet, but we can talk about the use case. The first one was in logistics. Do you want to give a kind of a rundown of the challenge that we were facing there and how it actually worked from your point of view as a kind of implementation guy?
Yeah, gosh, absolutely. So I can talk around it a little bit. I don't think people would be able to kind of guess the customer. But yeah, I approached them at a conference, had a chat to them about problems, as you do when you're a consultancy. And they brought up that they were having real problems with single view of customer. So as a logistics company that deals with multiple suppliers of their own, basically the origin of parcels, packages, deliveries, etc. They might have to deal with eBay, Amazon, all the usuals, Temu, Shein. These companies deal with multiple kind of last mile providers. we're receiving multiple different data formats, multiple different data types, multiple different levels of quality. They were encountering masking. So some of these companies mask emails. eBay in particular is notorious for that. Other ones would chop addresses in strange places. Other ones would only give you initials rather than full names. The formatting, it was horrific, right? They had this horrifying, to them, data set, and as you mentioned, they had failed previously with other solutions and other providers who will also not be named to kind of put this in and get it working. I took one look at it and went, Tilores can smash this. We did a very successful POC with them. It literally only took a couple of weeks to get their data schema in, do the resolution, set up the models, ingest over 100 million records, resolve those down to around 30 million, unique defined golden records, amazing precision, recall, accuracy. The false negatives and false positives were tiny, and they were completely blown away by it and basically said yes on the spot. It was very successful. I think the scale of the challenges and the problems they had before made them almost not quite believe that it could actually be simple when you use the right tools.
Yeah.
And with Tilores, genuinely, it was very, very straightforward to get some really quite extraordinary results.
Oh, that's great. And we're kind of rolling that out now, which is pretty exciting to see it, working at that scale on a very unusual use case. And it's not actually one I would have thought of if you hadn't met them at a conference. But that's, the kind of beauty of entity resolution, or maybe the beauty, but also the problem is, I've heard it described as the most common data science challenge that you don't know you have. Because almost every single company has this problem with what is effectively siloed, messy data. And everyone's running around trying to build AI things on top of the data without realizing that the data is actually pretty crappy. And it's like trying to build a fancy modern house on the beach without any foundations. But the problem I keep on finding is that people almost don't realize that it's a problem class of its own. Everyone's kind of used to needing to implement a data warehouse or needing to set up some kind of ETL pipelines and blah, blah, blah. But my feeling is that people think that this is a problem, A, that's not that complicated, and B, they can solve it themselves, or they don't bother. So what's your kind of experience of this as a consultant?
Yeah, gosh. I think there's two answers there. So one of them is around the problem people didn't know they had, or the problem they thought they would just have to live with forever and didn't realize they could solve. So one use case, for instance, which people didn't really think was solvable by this kind of solution, was in insurance, where remittances and claims needed to be matched. It involves names, also involves transaction quantities, involves, in this case, it was health. So health providers, hospitals, doctors, treatments, tests, all these things might be in a claim, and the remittance might go to potentially different parties, etc. So matching claims and remittances is an entity resolution use case. And it wasn't really until I spoke to this health insurance company about this scenario that they kind of saw the light and went, oh my God, yeah, we've got an entity resolution problem, and potentially something like Tilores could really solve that. So the whole use case you didn't know you had, or solution you didn't know was available, like absolutely we see that all the time. But in terms of the challenge of, oh, it's simple, we can do it, I think that comes a lot from effectively the Python community. So a lot of data scientists and data analysts use Python naturally. It's a very powerful tool. There are libraries that will do entity resolution. They've got Liebenstein distance, and so they go, well, I've got Jacquard, I've got cosine, I've got Liebenstein, I'm good to go, right? And then they try, and then I think you can probably talk best to their experiences when they do try it. But yeah, consulting wise, I'll 100% say in advance everything Stephen's about to say we've seen too. But yeah, do you want to talk about how people initially maybe think they can do it and then find out that they can't, and why they can't?
Yeah, I mean, that is, the people that come to us, I've usually tried to solve this already using one of three things. So I've tried using a graph database. Usually it's Neo4j. We tried Neo4j. We also tried Neptune. Didn't really work. Quite often they'll have tried to use a search engine. So very often they'll have tried using Elasticsearch, because conceptually it makes sense, right? I've got this new account, search in my database for accounts that are related to that one, and you find one other one, but then you want to find anything that's related to that one, so you have to jump again. So you end up with this horrible kind of transitive hop problem. So very often we're replacing Elasticsearch. And the third one, as you say, is the Python approach, and that's pretty frustrating, because they'll build some, the challenge here is that you can build some pretty decent matching. Like any good data scientist, take a sample of 1,000 or so records, a couple of thousand records, can build pretty good matching that will work quite well. But getting that into production is just about impossible. We see that time and time again, that people will build something that works on small data samples, but it's a quadratic problem, right? You've got to compare every single record to every single other record that's there to know whether or not there is some kind of link or deduplication necessary. You do that over 10,000 records, you got a significant number of comparisons. You've got 10 million people, the numbers start going a bit crazy. Obviously, there's techniques you can use like blocking and stuff like that, but it's still kind of making too many compromises. So yeah, we've even had someone say, oh, one of our engineers think they can solve this with some SQL joins. You're like, no, you can't solve this with some SQL joins.
Yeah.
And that's almost like it's not going to work. So you can say to them, fine, this is just going to delay us getting started by 3 months, but feel free to go away and try that out. The other thing that obviously we get asked a lot about now is AI and large language models, because Tilores, we're a rules-based system. The regulators, or we often are working regulated businesses, they prefer to have rules. It's more predictable, it's consistent, it's repeatable. You can fine-tune it very accurately. But I would say LLM can do entity resolution, right? If you've just got a little data sample, you want to do one-off kind of effectively deduplication, chuck it in Claude and you'll get quite decent results. Try and put that into production, and there's a whole raft of things which are not going to work.
Yeah, 100%. It's not a viable part of a large-scale data workflow. It's just not going to be, the token cost, the accuracy, and I mean, forget explainability, right? I mean, Tilores is literally 100% white box. You will see what matched what and why it matched it.
Yeah.
And it's stored against the record. So, yeah.
What we're planning to do is possibly, or probably, incorporate large language models as the equivalent of a human in a loop. So you do sometimes get those gray area matches where you're not 100% sure which a human can review, but if you want, you can potentially have a large language model doing that review. So for the low level or small volume of matching, it's potentially useful.
Yep.
Well, that's us. We've taken up our half hour. I suspect people will be either they're already eating their lunch while chatting with us or while watching us, or they want to go off and have their lunch now. So there hasn't been any more questions that have popped up. So we might be more or less free to go, but maybe we can just hang around for another 10 seconds or so in case anything pops in.
Yeah.
But yeah, very excited for 2026 and working on more projects with you, Max. So it's been a pleasure working with you in 2025.
Thanks, man. Catch you. Bye-bye.
Okay, bye now.